Welcome back, everybody. In this video, we're going to talk about function composition, and we're going to go through a series of exercises that will help us practice working with function composition and identifying function composition. And so what I want to do is start with something that we're already familiar with, is evaluating functions. So if we look here, I've given us a function g of x. And so if you recall, g, this is the name of our function. I'm using x to represent my input or my variable, and then the formula for my function is given over here. And so what we're doing is we're taking our input and we're squaring it, and then we're adding 3 times our input, and then we're taking away 7. And so that's our function that we have defined here. So let's go ahead and let's see if we can evaluate this function at 2. So the process that we use for evaluating a function at 2 is I look over here and I see that I have g of 2. And what that tells me is I want to first take my input, whatever it is, and square it. Then I want to add 3 times my input, whatever it is, and then I want to take away 7. So something that I often do when I'm thinking about function composition is I set up this roadmap for myself. So anytime I had an x up above in my function, I thought about putting parentheses around it. So I went ahead and I did something like this. Here's an x, let's put parentheses around it, and here's an x, let's put parentheses around it. Now, what this does for me is it tells me that these things over here, an x with parentheses around it, kind of looks like this over here, an x with parentheses around it. Now, whatever this thing becomes, doesn't matter what it is, whatever this thing becomes, these things also have to become that because they're my input. They're really the same thing. So in this case, if I want to evaluate this at 2, I would say, well, I need to make sure that instead of this x here, I have a 2, and instead of this x here, I have a 2. And so then I say, all right, here's my function, and we're evaluating it at 2. So this is 4 plus 6 minus 7, and that is equal to 3. So this second step that I just added in here, this 4 plus 6 minus 7 equals 3, we have that for evaluating functions, but we may not always have that. So let's take a step further, and instead of having a number that we're plugging in, my next step is to plug in a letter. So all of this is going to look exactly the same except for the fact that I'm not going to evaluate it. I'm not going to write out these numbers because there won't be any. So I am going to set up my roadmap. So my roadmap says take my input, square it, add 3 times my input, and then take away 7. And so then I look at what my input is. It's h, so this would be h squared plus 3h minus 7. And so if I want to take my function, I want to plug in h, this is what it would look like. Okay. So where do we go from here? Often what I see with students is these 2 steps are good. So these first 2 steps are not so bad because we're just placing it with one letter. But what I can do is replace this x with an expression. So it doesn't just have to be a one symbol. It could be a 2, it could be an h, or as we see down here, it could be an x plus 1. But if we use our roadmap, this is going to be exactly the same. So I set up my roadmap, my input squared plus 3 times my input minus 7. Now, I have an x plus 1 in those parentheses, so what I have to do is I have an x plus 1 here, that's my input squared, plus 3 times x plus 1 here, that's my input, and then we're good to go. So g of x plus 1 is equal to x plus 1 squared plus 3 times x plus 1 minus 7. All right, so this is our warm-up when we're working towards function composition. So I did it with what we call a quadratic function, and notice that every time I had an x in my formula, I replaced it with whatever that input was. So in this case, I had 2 x's here and here, and I replaced it in each case with whatever I changed my input to. So let's go down here and let's see another example. All right, so here's what I'm going to do. I'm going to pause again, so I'm going to be quiet for a few seconds. So if you want to pause the video at this point and work through these examples on your own, then we'll come back and we can work them together. All right, so welcome back, and let's go ahead and see if your work was correct. All right, so in this case, it looks like my function, what I'm doing is I'm taking my input, I'm multiplying by 2, and then I'm adding 7. So for each one of these things, I'm going to go ahead and set up my roadmap. And I have 2 times my input, whatever it is, plus 7. So in this case, my input was 1. 2 times 1 plus 7 equals 9. All right. So here's what I'm going to do. I'm going to go ahead and erase this A. I'm going to replace it with a different color. So let's make this a red A so we can see what's going on here. All right. So f of A, we'd have our roadmap again. It's 2 times whatever that input was plus 7. And in this case, our input is A. So I just put an A. So f of A is 2 times A plus 7. All right, let's do the same thing for this x plus 1 down here. Okay, so let's erase this and let's change the color. Let's make it blue. Here's x plus 1. And let's see what happens. Okay, so we have 2 times whatever our input is plus 7. And in this case, our input is x plus 1, so in here, I just put an x plus 1. Now, if we wanted to, we could expand this out and we could keep going with the algebra, but for our purposes here, I think this is good enough. Now, what I have below, this f of x, is a little bit different, admittedly. So what I'm going to do again is let's take this f of x and let's change the color. Okay, so I'm going to change the color to green. And I'm going to make this inside f of x green. Okay, so what we're doing now is this is the first time that we're going to see something called function composition. Okay, now what I'll do, and I'll learn a little bit, I'll define it more formally. But let's go ahead and take a look at what we have so far. So I'm going to give us a little bit more space. So 2x plus 7, that was our function. So let's set up our roadmap here. It was 2 times whatever our input was plus 7. So we've seen that a bunch. And now my input now is represented by this function f of x. So on the inside, I have a new function here, is f of x. So what I've done is everything on the outside, right? So in the black text, this f of here is represented by this black text here, right? So 2 parentheses plus 7. And then now I have this other f of x on the inside. So what I can do is I know what f of x is. I know it's 2x plus 7. So I can keep going. And what I'm going to do is I'm going to replace f of x on the inside with its formula, which is 2 times x plus 7. So what I've done is I've used one function as the input for another function. And so we've evaluated a function inside of a function, and this is what we're calling function composition. So this is fine. This form right here is fine. If we wanted to go ahead and simplify it, I could go ahead and distribute this 2 across, and I would get 4x plus 14 plus 7. And I group all my terms together. So this would be 4x plus 21. So f of x is the way we say that. Turns out to be 4x plus 21. Okay. So let's go a little bit further down here. And here's our formal definition. So if we think about this, what we had before is we looked at a function with another function plugged in as an input. So we have this g of x was the input for the function f. And so the way that we write that in notation is this is creating a new function which is called f of g. So remember, in our function notation, this is the name of our function. Okay, so this right here is our name. We use that little circle to represent function composition. Then this right here is telling us that we have a variable x. And then what we would have on the outside is this is our formula. Now, if we knew what f was defined as, and we knew what g was defined as, what we could do is actually come up with our full formula. And so that's what the next step would be. So if we go down here, I have 2 functions. So that's the 2 functions that we've used so far. F of x was 2x plus 7, and g of x was x squared plus 3x minus 7. So what I want to do as an example for us is to work through determining what is f of g of x. Okay, so what we saw just a moment ago was that the definition, the name f of g, so if I look over here as I'm reading it, f of g tells me that I'm going to take my function f as an outside function, and I'm going to use this one on the right, g, as my input. So this is what I want to evaluate. So just as I did before, what I'm going to do to help us out is I'm going to change the color here. So I'm going to go ahead and I'm going to erase this g of x, and I'm going to change its color to help us out. So let's make it red. Okay, so I look at my outside function. I have this f is in the black text, and I'm going to set up the roadmap for that. So the roadmap for f was 2 times whatever is my input plus 7. In this case, our input is given by g of x. Okay. Well, at this point, I mean, this is a fine representation for our function, but I actually can go a bit further because I know what the formula for g of x is. So let's go ahead and let's take that a step further. And instead of writing the red g of x, let's replace g of x with its formula. All right, so this is, so let's make it our black text again. So this is 2 times whatever is on the input plus 7. And g of x was x squared plus 3x minus 7. All right. So if we put all of this together, what I have is my function f of g is, well, here's what I'm going to do. I'm going to distribute this 2 to all of these terms here. 2x squared plus 6x minus 14. And then I have this I still have to take care of, which is plus 7. And so if I look at all my terms, all the terms with an x squared in it are right here. all the terms with an x in it are right here. And these two are numbers, so I'm going to put these two together. And my final result is going to be 2x squared plus 6x minus 7. So f of g of x is 2x squared plus 6x minus 7. And so this is a nice example of function composition. And so depending on how this goes, we may do some more examples of function composition here in the future. If not, what we'll do is move on to inverse functions in our next video. So I'll see you then.